Dear students, in today's lecture, we will talk about the structure of polymers. So polymers has very different structure as compared to metallic and ceramic materials. So polymers are long chain molecules consisting of many repeating units, or called monomers. So essentially, this is one chain of molecules, and this is another chain. So in these polymer molecules, you have carbon atoms serving as the so-called backbone of the chain. So you have carbon atoms here on the chain, and they are called the backbone of the chains. And the chemical bonding between the carbon atoms are covalent bonding. So very strong primary bonds. And the interaction between the chains really depends. So one type of interaction between the chains is just the secondary bonds, such as van der Waals bonds or hydrogen bonds. For example, if you have functional groups on the chain side, and you may have van der Waals bonds between the functional groups. And the interaction between the chains can also be the cross-link, so-called, or covalent bonds between the carbon atoms. So this is direct covalent bonding between carbon atoms in different chains. And this is called cross-link. Okay, so these are the complex interactions in the chains and between the chains. And depending on these interactions, polymers can be classified into different types. For example, if there's no cross-linking, which means if there's no covalent bonding between the chains, it is called thermoplastics. And if there are cross-linking, the polymer is called thermosets. And a particular type of polymer called elastomers is where they are thermosets, but they are light cross-linking. So the fraction of the cross-links are really low. Okay, so these are some terminologies regarding polymer structure. So monomer is the smallest or the minimum repeating unit of a polymer molecule. And depending on the number of units you have, you may have dimers or polymers. And if you have an unfulfilled chemical bond at the end of the polymer chain, it is called an activated monomer, which is at high energy state and which can be very reactive. And you may call the functional group at the end of the molecule chain as a terminator. Okay? So there can be different molecules on the same polymer chain, and they are called copolymers. And depending on the geometry of the different types of molecule units, you can have these random copolymer, block copolymer, or graft copolymer. And you may also have different chain structures. For example, you may have this so-called linear polymer or branched polymer, where the side branches are connected with the main chain, forming branches, and cross-linked polymer where are strong covalent bonding between the chains. And you can also have a star polymer where you have a common node at the center. And polymers can also be considered as crystalline or amorphous. However, the terms crystalline and amorphous are having different meanings as compared to those used in metals and ceramics. So for crystalline polymer, you have these ordered arrangement or regular arrangement of the polymer chains. And for amorphous polymers, you have these kind of random arrangement of these polymer chains. So to summarize a little bit, polymers can be classified into different types. If you define different polymers by the degree of their cross-linking, they can be divided into thermoplastics, where there is no cross-linking, or thermal set where there are cross-linkings. And if you define different types of polymer by their constituents, they can be having this homopolymer where all the molecules in the polymer are the same. And you may also have this copolymer where you have different types of molecules on the same polymer chain. And depending on the crystallinity, you may have a crystalline polymer where you have a regular and ordered arrangement of your polymer chains. And amorphous polymer means your arrangement of the polymer chains are totally random. Okay, here I just give some particular comments on thermoplastics, thermal sets, and elastomers. For thermoplastics, as we have discussed, the interaction between the chains of either van der Waals bonds or hydrogen bonds, which are relatively weaker secondary bonds. And the net result of this bonding nature between the chains determines the mechanical properties of thermoplastics. And particularly, these thermoplastics, they will become soft when they are heated. And finally, they will decompose. And such a mechanical properties will be discussed in more detail in the mechanical property chapter. So in terms of thermal sets, you already know that they are heavily cross-linked polymers. And the cross-links corresponds to the relatively strong covalent bonds. And those cross-linking can come from heat or chemistry. And they are usually much, much more stiffer than the thermoplastics because of those covalent bonds. And when they are heated, in terms of mechanical properties, they don't melt or soften significantly when heated, and they just directly decompose. The last type of polymers we are going to discuss is the elastomers. Okay? So elastomers are, by definition, some intermediate state between thermoplastics and completely cross-linked thermal sets. And as a result, it has some intermediate mechanical properties as well. So today we have briefly discussed the structure of polymers. Thank you.